Welcome to the first experiment, chapter 9. Do you remember the candy picking or chocolate picking race? What if that race allowed each child a specified time separately and also a specified number of candies or chocolates? Remember the competition. Children would go try to pick the candies as fast as possible or chocolates as fast as possible. Try to put it in their pockets, right? So the winner would be the child who picked the maximum number of chocolates, wouldn't it? Imagine knowledge to be the candy or the chocolate. Okay? Now imagine yourself picking information or knowledge points. First para of this chapter as fast as possible. Welcome to the chapter Light. Chapter 9, Light, Reflection and Refraction. Now I have picked a few points for you. You will have to pick more points. And the one who picks maximum points from this portion of your chapter gets a prize. So let's open the textbook and look at the first para of chapter 9. Go to line 3. See the question. What makes things visible or to be seen? Visible or to be seen. So the word visible is to be seen. Okay. What you see and what is visible are two different things. What you see is seen by you only. What is visible is actually visible to the entire human population. Okay. So let me read that question again. What makes things visible? Answer is light. You might say it's the eyes. Eyes helps you to see only if an object is visible. Okay. Now the answer is right. Can you see rays of light falling off to an object? In this case, the key, and being reflected into a pair of eyes. So what is being reflected? The rays. What is falling on the key? Again, the rays of light. Can you see that? This is what will help you to understand the ray formation which we will be doing later on in the chapter. For now, have a look at the rays falling from the light source of light, and it being reflected back to that pink cartoon's eyes. Okay, the rays are going back into the eyes, and that is what is going to help people see things. Okay, so if there were no light, there would be no light rays, and there wouldn't be any rays going into the eyes. And if no rays go into the eyes, we cannot see anything. Okay. So light makes things visible. Even when we have eyes that can see, we can see nothing in the dark. We can see nothing in the dark. During the day, it's sunlight. And during night, it's the light we switch on, which makes us see things. Okay. Now, do you see the light rays fall on object and from there changes its path and enters the eyes? Can you see the rays changing its path? First, it goes and hits the object, the light rays. Then it enters the eyes. I'm trying to make you understand why we are going to learn about the light rays. Just as charges move along the path of current, photons move along the path of light. So let me introduce you to the cartoon photon also. Okay. Here you can see two cartoons, positive and negative charge, running along a wire. Okay. Can you see that? So when charges move from the positive side of the circuit and completes that path, we see the bulb glowing. But for this light rays, what happens is tiny photons. Now, photons are tiny energy packets. Let me show that to you. See, I've made that photon as a carbon. Okay. Hi, I'm photon, says the photon packet. Now, photons are those tiny yellow dots that you see emanating from the torch. Now, torch was earlier a, something which was lit up, matchstick would be put on to some cloth with kerosene or a bunch of leaves held together, and the end would be bright. Okay, because they were flames of light, and that is how people find their way in moving times. So this torch here has flame of light. From there, photons are scattered along the rays of light, and those photons are energy packets. And when photons enter our eyes, so the path of photons is traced by the light rays. Okay, we didn't know so much about photons now, but that concept that a light ray has to first hit an object, and then that ray has to be reflected or uh, its direction is changed, go into our eyes. Okay. So we learn about reflection, refraction, and all. But now just know that light rays start from the source of light. So from the bulb or from the torch, it starts, then it goes to the object. After reaching the object, it will bend and change direction. And some of the rays don't enter our eyes at all. But the ones that enter our eyes are responsible for creating that object. That is how we see. So, photons are tiny energy patterns. We'll learn about that higher classes. Okay. So, just about the photon carbon here, you will see a photon enlarged version, which I have shown with energy diagram, so that you should know that it is just a packet of energy, with small packets of energy, which cannot be so clearly seen as when it is moving as a ray, just like you cannot see the, we say, charges, electrons or protons moving along a wire, but we know it's there. Okay, let's do this experiment. Now, this has to be done when you can make the room dark. So, wait till evening when it's dark. Take a cardboard box, or you can just keep it on the table. But if you want to do the experiment, you take and you have to cover the entire object with something, with a box or something, so that the object lying inside the box is not visible unless there is light. If it is open, light is always there during the daytime. But better to do the experiment at night when you can make the room dark, and hold a torch in your hand. So switch off the light, put the torch in your hand, switch it on, put it on. Suppose you keep a key inside a box. Okay. There, right in front of you, you can see a key inside a box and a torch being lit from the top. So because light is falling on the key, you'll see the key. Make the torch dimmer, slide it upwards. As it becomes dim, the key becomes less and less visible till you switch it off and then nothing is visible. Okay. Here, key is clearly visible. Now dim the light. Now the light has been dim. You can barely trace the key. Can you see? The light is very dim in it is getting down. When the lights dim, less photons come out of the light source, enter the eye, and the key is less visible. Can you see that? So the number of photons is less. In the earlier picture, there were a lot of photons. I'll show that again. See, there are two pictures here. The first one shows a dim light and the other one shows a bright light. Now the picture where the light is dim, there you get to see that the number of photons is less. Okay, so imagine this in your eyes when we are drawing the ray diagrams later on. Okay? Now, when light dims, what happens is that number of photons reduces. So, less number of photons reflect and travel from the object to the eye, from the object to the eye. So, the key is less clearly visible. When there is less light, key is less visible. When the light is bright enough, you can see the key clearly. And when there is no light, he will not be visible. So eyes is still working fine. You need light. Now notice the path of light rays. We will be studying about these paths in detail in this chapter. Now here when light is positive, he is very still. It's very light. You might miss it also. When no light is there, he cannot be seen. Now here, this is the first para seen in your text. This is the introduction portion. Now from here, three keywords will be explained to you so that you can find more keywords or points that you want to remember, and you will make those points and send it to me. One who sends me the maximum number of points from this paragraph is the one who is winning this competition, where you find information which not everyone can find. Okay, so try to understand what I'm explaining so that when you read the chapter, things are more clear for you. Now, we see a variety of objects in the world around us. However, we are unable to see anything in the dark. On lighting up the room, things become visible. So, what does visible mean? That it can be seen. Example, when you click the video button on this, you are visible to me. So, if you don't click that video button, I cannot see you. So, you are not visible. I am visible to you when I make myself visible. If I'm screen sharing and hiding my image by switching off the video button, then I'm not visible for you. Yeah. The next word that you have to understand is transparent medium. Now, this is on the sixth line. Okay. Transparent medium. Can you see? This means transparent means that you can see through it. See through. You can see it. Also, you can see through it. What does that mean? You can see the glass lying on the table. It also, if there is an apple lying behind that glass, a tumbler, which is not made of steel, but glass, a drinking glass. Okay? That is made of glass. So if you keep an apple behind it, you can see through this glass. But if you keep a steel glass and keep an apple behind it, can you see through it? You cannot. The third point here is optical phenomena. Optical phenomena is a fact or an event in nature or seen around us, especially one that is not fully understood. So we call something a phenomenon, but we really don't understand what it is. It's like, we see twinkling of stars, but we do not exactly understand how it works. So those kind of things are called a phenomenon. Now read through this first section, that is intro portion of the chapter, and then get back to me with lots of points that you have found from this portion only, not from outside, from this section. And then let's see what prize you will be getting.